All right, so in this section, we're going to go over common light parameters, and these are parameters that you will find on all of the Redshift light types. So let's go ahead and drop down an area light in this case. Okay, so first we have preview, and this is just a quick toggle for if you want to see a representation of your light in the viewport, as well as a representation of the illumination. This is not going to be at all accurate to what's happening in Redshift, but I don't know, perhaps you want to see it. As well, we have a illumination adjustment, and this is strictly in the viewport as well. As I scale this up and down, the intensity of our light in the viewport scales as well. All right, let's get rid of that guy and take a look at general. So initially we have mode up here at the top. There's color, which allows us to just pick a color for our light. We have a temperature option, which is going to let us choose our light color by temperature. The lower the temperature, the warmer the light will be. The higher the temperature, the cooler the color will be. And lastly, we have temperature and color, which is kind of a weird one. Let's say I've got like a kind of warm yellow light. I'll increase my intensity so you can see this. As well, I can then make that yellow color warmer or cooler, which is going to give us kind of like a green color, especially if we crank the color up here. Not sure when you'd want to use that, but you know, it's there for you. Let's flip this guy back to white and flip back to color. Right, so we also have a image texture path, and this allows us to light our scene with an image texture. You can see back there in my reflection, actually I'm gonna need to dial this up a bit. Let's try 25. You can see in my reflection back here, now I've got this softbox material appearing. As well, my scene's being colored by the color of the image. We have an intensity multiplier, which is just a linear scale on your light intensity. And then we have exposure, which is a exponential scale on your intensity. And this can be super useful if you are, for example, lighting something and maybe it's just a little bit too hot or maybe a little overexposed and you're like, boy, I wish I could just stop that down like one stop. If I type -1 into the exposure, we stop down by roughly an exposure stop. And this can serve two purposes. One, can give you a bit of a photographic feeling adjustment for your lights. As well, it can keep us from having absolutely nutso numbers like 8,000. In this case, 8,000 is super bright, but like if my light was really tiny, instead of typing in 8,000, I could type in 10 and dial the exposure up a bit, and then be able to keep my intensity multiplier numbers at a reasonable scale. All right, let's flip those back and bring our light back up. Okay, next we have decay. Honestly, I doubt you'll ever touch this, but in case you were curious, this describes the rate at which light decays from the source. So I just want to talk about inverse square just for a second so that maybe you'll have a little bit better idea of what that actually means. So if we imagine a point on our light of intensity I, and we imagine a sphere around our point with radius r, with a hole in the sphere that the light is casting out of. If we then take a sphere that is twice the size, i.e. twice the distance, and project that hole onto the sphere, we're going to notice that the area of our hole is actually, we're going to notice that the area of our second hole is actually equal to 4 times the size of our first hole. Actually, I should have drawn this pink circle a little bit bigger. This is definitely not to scale. So if our intensity in hole number 1 is I, then the intensity in hole number 2 is going to be I over 4. So at 1r, or a distance of 1 radius out, the intensity is I. At a distance of 2r, our intensity is I over 4. If we added a third sphere around this whole debacle, we would be at 3r, and our hole in the sphere would be 9 times the original size of our first hole, which would be I over 9. So what we can conclude is that as the energy travels farther and farther away from the light, it has to take up more and more space at a rate that is the original intensity over the distance traveled squared. So if it's 1 unit away, it's I over 1. If it's 2 units away, it's I over 4. If it's 3 units away, it's I over 9. If it's 4 units away, it's I over 16, and so on and so forth. The TLDR is use inverse square. All right, the area light tab is unique to the area light, so we'll go over that in the area light section. We have a ray tab, and on the ray tab we'll see we have the option to exclude the light from diffuse or spec. We have matte shadow illuminator, which if you'd like to know more about this, check out the matte shadow section. We've got individual contribution weights to diffuse, spec, or reflection, or here it's called glossy. Single scattering, which we go over in the material section, as well as multiple scattering, and global illumination contributions. Kill the image for a second so that we can see the GI contribution a little better. So if we take a look over here on the right side of the dragon, you'll see right now we're getting GI contribution from the light, whereas if I slide it down, we are no longer getting that contribution. Volume we'll go over in the volume section. Suffice it to say that you need to set contribution scale to 1 in order for your light to affect volumes. We also have light group option, and we'll go over this in the AOV section, but just briefly, this allows you to create light-based AOVs. So for example, in that AOV, you'll only see that specific light contribution. We have shadow, which we have enabled here. If you untick the toggle, you'll see we're no longer tracing shadow occlusions. As well, we have shadow transparency in case you want to lighten your shadows. If I quickly switch over to the point light, dial up my intensity, you'll see we have an option for our shadow softness. It's going to give you just a little bit of softness in your shadows. As well, we have samples for shadows. Photon we'll go over in the caustics section. So now we have the project tab, which works just like C4D Light's project tab. So if I take my red plane back here and throw it into the exclude list, you'll see it's no longer being affected directly by that light. And then target is just the target that I added on there. Right, so lastly, I'd like to go over the add shader graph option. We'll flip back over to the area light for a second. Dial the intensities back down. And this basically lets us get a bit more prescriptive with our description of the light's surface. By pressing that button, it will add a new material into the network. If we give that a double click and take a look, you'll see we get the physical light node, which more or less is the same thing as the general tab of the light, which you'll see is now fully disabled. So this, for example, lets me add an image texture to our light. We'll add that warm softbox texture again and pipe that into color. And this just lets me get a little bit more prescriptive, like I said before. So for example, we could add a color correct in there and adjust, the hue of our light, or perhaps the contrast, our saturation, things like that. If at a point you're like, I don't need all that, you can just hit the remove shader graph button. The general tab will become enabled again, and it will get rid of the shader network that it created. There is a little icon off to the right hand side as well that lets you add a target tag, just a quick shortcut. And also you can add a target tag with a null, and we get our null here, which acts as the light target. Kind of spiffy. And that'll just about do it for the common light parameters. If you'd like to know more about a specific type of light, go ahead and check out the other light sections, where we'll go over all of the light types in this list.